Hello all, welcome back to this new module. From this module onwards, we are actually going to start with the iOS pen testing. Now, pen testing a particular application, a particular mobile application has two aspects of it. One is called the static analysis. The second is called as the dynamic analysis. In the static analysis section, we are not going to capture the request and the response that are being sent by the application. Instead, we are just going to accept the application and find certain vulnerabilities that are present with the particular application, that are present in the source code of the application. So for example, in the static analysis, we can check out whether the application has certain hard-coded keys installed in it or not. We can check out whether the application is allowing certain insecure permissions to be used or not. We can check out whether the application is using insecure encryption techniques or insecure hashing algorithms or not. So all of these examples comes under static analysis. And dynamic analysis, what we are going to do is we are going to capture the request and the response that are being sent by the application. And once we capture the request and the response that are being sent, we are going to play with those requests to find logical vulnerabilities or to find vulnerabilities that are present inside the application's logic. So that is the difference between static and dynamic analysis. So let's start with the first one, that is the static analysis. So in order to start with the static analysis, let's first define what static analysis is. Static analysis is about decompiling the IPA file and checking out for source code related vulnerabilities. So certain examples, as we have already discussed, include checking the info.plist file, checking out for file permissions, checking out for insecure APIs and functions that are being used. Now, to perform static analysis, you can have one way, that is the manual way, wherein you take the IPA, you decompile it, and you go through each and every file. And the second way out is using an automated tool. Now, the automated tool that we are going to use over here is called as MobSF. Now, you can always go and do the manual procedure. You can manually find out the source code. You can manually decompile the IPA file, find the source code, and find the code level vulnerabilities. But that's going to take a lot of time. Obviously, you have to manually go and visit each and every line of the source code. You have to check out whether this line is vulnerable to any particular vulnerability or not, whether the logic implemented by the application is correct or not, and all of that things. While MobSF, that is an automated security framework, will help you out to find all these vulnerabilities in an automated way. So what is MobSF? MobSF stands for Mobile Security Framework. It is an automated all-in-one mobile application pen testing framework that helps to perform runtime assessment. And a beautiful feature of MobSF is once the vulnerabilities are found by MobSF, you can download it inside a PDF format as well. MobSF is open source and it is very simple to install. So let's check out how you can install MobSF. MobSF comes with all the three operating systems, the majorly three used operating systems. You can install MobSF inside Linux and Mac, as well as you can install MobSF in Windows as well. All you have to do is just git clone the particular repository that you can find on GitHub. You can go inside that particular repository and you have to double click or open the setup. Once you complete the setup, MobSF would be installed for you. So it's the demo time and let's check out how you can install MobSF inside your device. So over here, I'm on to github.com, MobSF, the MobSF's official GitHub repo. I'm going to copy the particular link, go on to my terminal and git clone this particular link. Once I git clone it, okay, I already have it installed. So I'm just going to go inside the directory and I'm going to run setup.sh. Since I'm onto my Mac machine, I'm going to run setup.sh. If you're onto your Windows machine, you have to run setup.bat. You have to double click setup.bat. And if you want to install this using Python, you can run python setup.python3 setup.py install. Okay, since I'm onto my Mac machines, I'm just going to run setup.sh. Even if you're on Linux machine, you can run setup.sh. Once I run this, MobSF is going to get installed for me. Now what I've done is, for me, MobSF has already been installed. So after the installation is completed, you have to run another command that is called as /run.sh. Once you run this, okay, MobSF is going to run, and over here, as you can see, for me, MobSF has been running. All you have to do is MobSF is going to run for you onto a particular URL and onto a particular port number. You have to enter that URL and the port number inside your web browser, and this would be the screen that would be displayed. Okay, now let's check out how you can analyze a particular application. Now, in order to analyze a particular application, all you have to do is click on upload and analyze. Okay, once you click on upload and analyze, you have to visit where your IPA file has been downloaded. Just double click the IPA file and click on open. Once you open it, MobSF is going to upload that IPA file, and MobSF is going to take some time to analyze the IPA file and find certain vulnerabilities inside it. So for saving time, what I've done is I have already uploaded it and I have created the report. I've uh, just displayed you the screen which MobSF would display after uploading and reviewing the application. So once your application is uploaded and reviewed, you can see over here, MobSF for the first time gives the security score. What is the file name? What is the file size? It gives three hashes: MD5 hash, SHA-1 hash, and SHA-256 hash. It gives you certain app information. What is the application name? What is the application type? What is the bundle identifier for the application? SDKs, version, platform version, minimum OS version that the application is supporting, supported platforms, what are the architecture systems, sub-architecture systems, etc. So once that is done, you can also view the security score, that is 21 out of 100. So out of this security score, you can now know that this application might be vulnerable to a lot of vulnerabilities because the security score is very low. So once you do that, you also have the access to the info.plist file. So once you upload your IPA file inside the MobSF, you can just click on the view info.plist file and it's going to help you view the info.plist file. And this is the exact info.plist file which we have already seen earlier. So over here, you can just view it and you can find certain vulnerabilities such as which insecure permissions have been given, what are the minimum OS versions that the application is allowing, whether the application is allowing to communicate over an HTTP traffic or not, etc. So these are certain vulnerabilities which you can find using the info.plist file. You can go at the bottom and now you can see that there is a custom URL name that is com.highaltitude.dvi Swift version 2 that is being used along with the scheme that is being used, that is DVIA and DVIA Swift. So these are certain informations that can be helpful. Now, what MobSF beautifully does is instead of manually viewing the info.plist file, MobSF is going to give you a report wherein it's going to give you a column called as application permissions, and it's going to list all the application permissions over here. Whatever the application permissions are being used by the application, all of them is going to be listed over here. So as you can see, the permissions that are being used by the application is NS camera usage description, and the status for it has been set to dangerous. So MobSF was detecting that this particular application is using the camera and this could be a dangerous permission that has been assigned. And what is the reason that is given? The reason is to demonstrate the misuse of camera. Please grant it permission once. So this is what MobSF does. It gives you the application permission and it lists down all of those. Secondly, what it does is it gives you app transport security. Now, app transport security basically tells you whether the application should be communicating over an HTTP server or not. And that's what MobSF has raised the flag for. MobSF has said that the severity is high and the application transport security allows arbitrary loads to be used. So app transport security restrictions are disabled for all network connections. Disabling ATS means that unsecured HTTP connections are allowed and ATS has been dissolved. And HTTPS connections are also allowed and are still subject to default server trust evaluation. And that's what MobSF declares, that this permission that has been given to ATS of disabling is a dangerous permission and it should not be given. So that's what it has suggested, and you can include this into your report. Now, except for this, MobSF also gives you certain binary code analysis, which basically means that it gives you or it tells you whether certain insecure functions or insecure APIs are being used or not. So, for example, here for this particular application, uh, MobSF has given binary make use of insecure APIs, and insecure APIs such as fopen, strncpy, memcpy, strcpy, printf, strlen. Now, these are dangerous APIs or dangerous functions that should not be used because they might leak certain data due to buffer overflow vulnerabilities or insecure information storage vulnerabilities, and this could lead to leakage of personal data. So these functions or these APIs should not be used. Instead, secure APIs or secure functions should be used. Also, with the insecure APIs, MobSF has also given that this particular application uses insecure random functions as well, such as underscore random. Now, this underscore random is an insecure random function, and it makes use of insufficient random values. Now, over here, as you can see for both of these rows, MobSF has also declared what is the CWE, that is the common weakness enumeration ID, that is 676 for insecure APIs and 330 for random functions, insecure random functions. And it has also given you what is the OWASP top 10 2016. So for insecure APIs, as you can see, the OWASP top 10 2016 is client code quality. And for random functions, it is insufficient cryptography. So you can include these vulnerabilities inside your report as well. But wait a moment, you cannot directly include these vulnerabilities inside your report without any proof. You need a screenshot wherein you can show the developer that these functions are used by the application. Okay, you just cannot display the MobSF report and ask the developer. You need a thorough proof that these functions are being used. Now, how will you get that proof? I've created a video for it later in this particular section only. So please watch that video. Inside that video, you would be able to know that how you can get that particular proof, that you can show it to the developer that these functions are being used. Now let's continue further with the report of what MobSF has generated. Okay, I'll just fast forward this. Now, as you can see over here, MobSF has also generated that this particular application is logging certain sensitive information inside logs. And how does MobSF come to know about this? MobSF has seen that this particular application is using the function nslog function for login. Okay, so sensitive data, MobSF predicts that sensitive data might be reflecting inside the log files. So using this particular output of what MobSF has given, we can now know that if logging has been enabled, we can also check out the logs to find certain sensitive information. Now, how do you check out the logs and how do you find sensitive information? I've covered a whole video on that as well later in the section. So you can view it over there. Now, for this particular parameter, MobSF has given it as info. Why it has given it as info is basically MobSF does not know whether sensitive data is being stored or not. If sensitive data is being stored, obviously we can raise the bar. Okay, we can raise it and tell that since sensitive data is being stored inside the logs, this might be a medium level vulnerability, a medium severity vulnerability. The fourth point which MobSF has reported is binary make use of malloc functions. Now, malloc functions are functions that can lead to memory leakage. So that is the CWE ID 789, uncontrolled memory allocation. And instead of malloc, it is always good to implement calloc, that is CALLOC. That is a secured memory allocation function. So again, this can be reported. Insecure usage of memory allocation functions, malloc. This again comes under M7 client code quality. Then you have binary use of WebView components. Now, this is again informational. This basically states that the application is using WebView, and if the application is using WebView, you can implement you can try to implement if any JavaScript related vulnerabilities such as XSS is implemented, or XSS can be exploited inside the mobile application or not. So that's the reason this is again an important point wherein we can know and we can try out certain WebView related vulnerabilities such as XSS. Now, moving forward, you have a detailed binary analysis as well. So the detailed binary analysis is whether ARC, that is automatic reference counting flag, this flag is being used or not. And if you see over here, this flag is being used. So if you can see, the status is true. So ARC is being used. Code signature, the binary has a good code signature. Whether the binary is encrypted or not, it is false, which means the binary is not encrypted. And you can see the severity over here is warning. Warning basically means the binary is not encrypted. And by default, the binary should be encrypted. So again, you can raise this finding inside your report that the binary is not encrypted. Then you have the NX bit that is set to true, the PIE bit that is set to true, the R path that is set to true. Now, R path that is set to true is again a warning. Why? Because the R path should be removed. Okay, remove the compiler option dash R path to remove @rpath. So rpath should actually not be set. However, rpath is being set. What is rpath? Rpath is basically run path, search path, and it is a feature that helps the attacker to execute the binary, that helps the attacker to run the particular binary. So this should not be set to true, and hence MobSF has given the warning. Then you have the stack canary, that is true. So that should always be set to true. And then you have symbol stripped. This is again a binary. It's set to false. However, it should be set to true. Then you further have the file analysis. What are the different files that are being set? What are the certificate hard-coded files that are being set? What are the server locations? So if you see on this particular map, it tells you what are the server locations. The server has which domain addresses registered. So you can see domain dgcert.com, which is registered, CRT Apple, GitHub, Google, example.com, highaltitudehacks.com, etc. So these are certain domains which are being registered inside the server or the server certificate. Then you have all the other URLs which are mentioned over here. If there are any Firebase database link that has been found inside the mobile application, it would be displayed inside this. So for this particular application, there is no Firebase database link that has been seen or that has been found inside the mobile application. So hence it is not displaying over here. But if there's any Firebase database link, it would be displayed over here. Then you have all the different email addresses that are being used inside the application. And where are these email addresses? You would be finding the file for it onto the right column. So there are email addresses such as pest123, default rem at host.com, pratik at damn vulnerable iOS app.com, etc. So these are certain email addresses. Then you have certain trackers. So you have a Google Analytics tracker and the URL for this particular Google Analytics tracker as well. If there are any hard-coded secrets that are being stored inside the application, such as API keys or let's say session IDs that are hard-coded and saved, all those would be grabbed and would be shown over here. You would be seeing under possible hardcode secrets. Then you have all the libraries that are being used, all the assets that are being used. So you can see the files that are being used. This are PNG files, text files, the source code files, etc. So these are all the files that are being used. And then finally, we have the option to download the PDF report. So you can click on print report. And once you click on print report, okay, sorry, you can click on PDF report. And once you click on PDF report, the entire report gets generated for you. And the report is so smart that first it gives you the finding summary. So in the finding summary, you can see there are 4 high vulnerabilities which are found, 3 medium vulnerabilities, and 2 informational vulnerabilities that are found. So it is going to give you the vulnerability count, it's going to give you the file information and all of those details which we have already seen before. And you can download this particular report or directly go and take a print of it as well. So this is it for this particular video. I hope you understood how you can use MobSF and how useful MobSF is. In the upcoming videos, we are actually going to see that how you can prove that the MobSF related vulnerabilities are actually present inside the vulnerable application. So I hope you like this particular video. Thank you.